Okay, good morning students. Today we will revise the chapter 6, that is factorization. Okay, the first we must know about the polynomial, an algebraic expression in which the power of a variable is non-negative integer, then that expression is called polynomial. And the greatest power of the variable is called the degree of polynomial. Say for example, here 3x cube minus 4x plus 5. It is a polynomial. Why? Because the power of x is 3, which is a non-negative integer. The power of x is 1, which is also a non-negative integer. And since the greatest power of the variable is 3, it means it has 3 degree 3, which means it has 3 roots. Now, another example, 5x plus 1 upon 5x minus 1. 5x plus 1 upon 5, x raised to the power minus 1. Now this is a negative integer, and as per the definition of the polynomial, the power of a variable is non-negative integer. Hence this expression is not a polynomial. Now linear polynomial means where degree is 1. Quadratic polynomial whose degree is 2, cubic 3, and biquadratic 4. Say let fx we will call it a polynomial in x. Let fx is equal to x square minus 3x plus 5. Now if you need to find out f2, what we are replacing over here? X with 2. So in the expression or in the polynomial, you have to replace x by 2, and then simplifying we can get the value of f2 is 3, f1 by 3 is equal to 4 1 by 9, and so on. Now remainder theorem. Now students, please remember that this theorem is very important. In exercise, in all the questions you have to apply remainder theorem. Now remainder theorem states that when fx means it's a polynomial in x, when fx is divided by x minus a, let x minus a is equal to 0, then x is equal to a, then remainder is equal to fa. The students, I am repeating it again, it's very important. This theorem has to be applied in each and every question of the exercise. Say for example, find the remainder without division on dividing 3x cube plus 5x square minus 11x minus 4 by 3x plus 1. Let fx is equal to 3x cube plus 5x square minus 11 minus 4. Now remainder is equal to 3x plus 1 is equal to 0, x is equal to minus 1 by 3. The remainder will be f minus 1 by 3. That means we have to replace x by minus 1 by 3. Now substituting the values of x in an expression or in a polynomial and simplifying it, we get 1 by 9. That means if we divide this expression or polynomial by 3x plus 1, the remainder will be 1 by 9. Now let us find out the factors of 12. Now factors of 12 are 1, 2, 3, 4, 6 and 12. Let 12 be divided by one of its factor 2 takes 6 times 12, remainder is 0. Let us divide 12 by its another factor 4, say the 4 3 is 12, again remainder is 0. So what we see that if a number is divided by its factor, then remainder is always 0. If a number is divided by its factor, then remainder is always 0. So here this leads to the factor theorem. Say if x minus a is a factor of fx means the polynomial in x. If x minus a is a factor of fx, then remainder, we have to apply the remainder theorem. For that, x minus a is equal to 0, x is equal to a. So remainder is equal to fa, and that remainder is equal to 0. Now, example, show that 2x minus 1 is a factor of 2x square minus 11x plus 5. Let fx is equal to this polynomial, then remainder 2x minus 1 is equal to 0, equate x is equal to 1 by 2, finding out the value of x, and then substituting the value of x in the expression. Now it comes out to be 0. Since remainder is coming 0, therefore 2x minus 1 is a factor of fx.